clearly understood only if you know the concept of TIR. I said you, TIR is a phenomena which takes place when light enters from a denser medium to a rarer medium. Always remember that. TIR can take place only if the light is entering from a denser medium to a rarer medium. Otherwise, it cannot happen. Second condition is light entering from denser medium to rarer medium. There are three possibilities. One possibility is if the angle of incidence is less than critical angle, if the angle of incidence is equal to critical angle, and if the angle of incidence is less than critical angle. For that, you must remember, I told in the previous class, what is the meaning of the word critical angle. I said critical angle is that angle of incidence for which the angle of refraction is 90 degree. So, the light is going from one medium to another medium, and for a particular angle of incidence, if the angle of refraction becomes 90 degree, then this angle is called as what angle? Critical angle, C. So, critical angle is that angle of incidence for which the angle of refraction becomes 90 degree. I told this to you. Did I say to you? Yeah. Then what I said to you? After that I said, if the angle of incidence further increases, that is angle of incidence is more than the critical angle, then the light comes back in the same medium, and this phenomena is called as total internal reflection. I will repeat this. Whenever the angle of incidence is more than the critical angle, then the light tends to reflect back in the same medium following the laws of reflection. It means whatever is this angle, the same will be this angle. Angle I will become equal to angle R. So, laws of reflection will start getting followed, and this principle is called as TIR. So, keep this in your mind. It will once again repeat in 12th standard also. If angle of incidence is less than critical angle, you will see refraction of light. If angle of incidence is equal to critical angle, you will see grazing. Grazing is when the light just goes on the surface like this. It will graze, it will not bend. And if I is more than C, then you have total internal reflection. I taught this thing to you or not? I hope you remember this. So, by using TIR, I talked next thing to you about rainbow formation. So, I said that rainbow forms with the help of three properties. One is refraction of light, second is dispersion of light, and third is total internal reflection. Remember that if this is the water drop, I said to you how it takes place. Light has to come, first it has to refract, then it has to TIR, then dispersion. So, in this case, you have all the three things visible to you, and you must be standing here in order to see the total internal reflection. That is actually rainbow formation. So, I said you, if you want to have a rainbow formation seen by your eyes, then you must have sunlight, you must have rain, and you must be positioned correctly if you want to see, or if you are likely to see rainbow formation, right. All these things I have taught to you in the previous class. Today we are going to complete the remaining topics of this chapter. Give the next heading in the notebook as atmospheric refraction. Next topic in this chapter is atmospheric refraction. Please, everybody, atmospheric refraction. Questions are coming from here. A lot of theory questions are coming. Lot of MCQs are coming from here. So, I will also show the questions how it comes from this topic in the board examination. Okay, what is the meaning of the word atmospheric refraction? So, I hope you are much aware about how the earth is, how the earth looks like, and earth has an atmosphere around it, right? Everybody aware about that? We have different layers of atmosphere, mesosphere, ionosphere, stratosphere, troposphere. Have heard about it in geography? Studied, no? Somewhere? Yes or no? We have different layers of earth, and I hope you are aware that different layers of earth or atmosphere of earth has different components of gases. Its thickness is different, its depth is different, its formation is different. It's not like equally everything has same size, everything has same density, everything has same gases, not like that. Different layers of atmosphere have different properties. I hope you are getting my point. So, this is the earth, then around the earth we have layers of atmosphere, like this I am drawing some layers. So, whenever the sunlight is coming or any light is coming from outside, the light has to cross all these layers and come. Are you getting my point? So, if you are seeing a star How you are able to see the star? Because light from star is reaching your eyes. Are you aware that sometimes we see a star, the star may not be there in reality, because star takes light years to come here, millions of light years. So who knows, by the time it has reached your eyes and you are seeing it, it is already vanished. So how you are able to see a star is because of the light from the star. So star is giving out light like how our sun is giving light. Our sun is also a star. From there the light comes and the light enters the atmosphere. Once the light enters the atmosphere, don't you think that light is changing its medium? From vacuum, it is coming to a particular medium. That medium also, when it goes from one atmospheric layer to other atmospheric layer, it is once again changing the medium. Like that, if you have 4 layers of atmosphere, every layer the refraction once again takes place, once again takes place, once again takes place. So light undergoes multiple bending. Suppose I am standing here and light is coming from here, one star is there twinkling. Why it is twinkling we are learning. So light rays comes, it refracts, right? Once again it refracts. Now based upon how is the layer, it will be decided whether it is going to be bending towards normal or away from the normal. One thing is very sure, when it is entering the first layer, it will bend towards normal only, because it is obviously rarer medium, it is denser medium. After that, based upon the density of different atmospheric layers, it will decide whether it wants to go towards normal or away from normal. After suffering multiple bendings, it is going to reach your eyes. Suppose it is reaching like this. Now if it is reaching your eyes, what you will see will be the path exactly in the line of your sight. So star is actually present here, but you are seeing it present here. That too, don't think our atmospheric layer is always having same size. It's not a bounded layer. It is not made like a crust or something. It is like gases. So its thickness may change. It may become thin. It may become a little thicker. Am I right? When that happens, the position of star keeps on changing for you, and this only gives the effect of twinkling of stars. So we say star is twinkling, right? Twinkling is because when the light ray is coming from the star, it undergoes multiple atmospheric refractions, and once it is going multiple atmospheric refraction, the position of star that you see from the earth is not its real position, it is apparent position. That too, this apparent position keeps on changing, it does not remain constant, and this change in apparent position of the stars gives a combined effect of twinkling, and that is how twinkling of star takes place. Are you getting what I am trying to say? First you give the heading as atmospheric refraction and write its definition, right? Refraction of light when it travels through various layers of atmosphere, when it travels through various layers of atmosphere, is known as atmospheric refraction, is known as atmospheric refraction. Is known as atmospheric refraction.
Sir, did you take anything last week?
Last week I have taught, man. I have taught about TIR. If you want to check what I have taught in the last class, I will share the video link with you. You can go through that video later. Okay, Pritam? Okay, yeah. So I hope you wrote a definition of atmospheric refraction. Next you write twinkling of stars. We are talking about twinkling. This question comes in the board exam also. Twinkling of stars, how it takes place. Twinkling of stars. And you can write various layers of atmosphere, various layers of atmosphere, various layers of atmosphere makes the observer on the earth, makes the observer on the earth, makes the observer on the earth to have apparent position of star, to have apparent position of star. Since this atmospheric, since this apparent position, since this apparent position keeps on changing, since this apparent position keeps on changing, stars seem to twinkle, stars seem to twinkle, star seems to twinkle. Stars seem to twinkle. Got it? So, there is a very simple thing, once again I am repeating because some students have come just now. So, Preetham, you also can pay attention. Suppose we have our earth. I said to you, earth has various atmospheric layers. So, suppose the light is entering the earth, it will undergo a refraction. So, we will draw normal and it will bend. Once again it will bend, once again it will bend. By the time it is reaching your eyes, it will have a new position, which is called as the apparent position of star. This is the real position, and because of atmospheric refraction I got a apparent position. And this apparent position also is not going to be static, because light is coming from very far source. By the time light is reaching you, the atmospheric layers are changing its formation itself. See, light takes millions of years to come to you. You know this light from the star, how much time it takes? Millions of years. So, when it is coming, the atmospheric formation is changing, and so every time we have different positions of star, and since we have different positions of star, combinedly it is giving a twinkling effect to you. So, stars twinkle because of atmospheric refraction. If the question comes like, what is the yeah, I'll come to you, Preetham, once again. If the question comes like, what is the cause of twinkling of stars? What is the answer? Atmospheric refraction. Come, Preetham, what you are asking, please.
Sir, if that's the case, then why do planets not?
Yes, good question. We know that we have some planets. For example, you can mute, yes. Venus is there. Venus also looks like a star to us. You know this or not? Venus looks like a star to a human eyes. If you see Venus and if you see other stars, you will not be able to distinguish so easily until you are knowing that it is a planet. You will think that it is also a star. So, his question is, good question by Preetham, that why do planets don't twinkle, why do stars only twinkle? See, understand the difference between how you see a planet and how you see a star. When I see a planet as a star, looks like a star, it is coming because of reflection of light, am I right? Do you think planets have their own light? No. Planets reflect the light of sunlight to us, right? Like how moon is doing. Same like that, first light falls on the planet and the planet light falls on the earth, and we see from here. Light coming from a planet is light coming from a nearby source compared to star, which is comparatively millions of times away from the planet. If you take a light coming from nearest star, which is Alpha Centauri or Proxima Centauri, they are near stars. That star, and if you compare the distance of Earth to the Venus, no comparison, that much difference is there. So, when light comes from very far, it becomes an infinite source for us, that is very far source for us, and star is emitting its own light. But here the light is travelling from a planet. Planet being nearby, there are multiple ways from where the light can come from this planet. But from star it comes from very far. It's like looking like a parallel stream of light coming on the earth. So there is change in the apparent positions of the stars, whereas if you see the light coming from the planet, it is coming from a nearby source. Since it is coming from a nearby source, this apparent position change will not be there. I said you, light is taking too much time to come from there. It is taking millions of years to come from here. But from the planet it takes only few minutes to come. From sun it takes 10 minutes to reach the earth's atmosphere. By reflection it will take, from planet is near than the sun, so it takes minutes of time. But from star it takes millions of years of time, which causes the atmospheric layer to continuously change by that time when the light is coming, and that is causing a change in apparent position. Are you getting my point, Preetham? Light is a very far source, but planet is comparatively nearer. That's why it is not twinkling. Got it? I hope it is clear to you. Theoretical question, it comes in the board examination also. Let us next talk about, continuing the atmospheric refraction itself. The next topic, give the heading as advanced sunrise and delayed sunset. Advanced sunrise and delayed sunset. Let us understand this concept, what happens. So, you know that what is the meaning of horizon? Any idea? You know what is the meaning of the word horizon?
So it is the point where the land and the sky seems to meet together.
Where do you see that? Can you see it everywhere? Laksha, where you can see the horizon best?
In the beaches.
Yes, in the beaches. We can see horizon good in the aeroplanes. If you travel, you can see, distinguish between the layers. So horizon is basically imaginary line, okay, which we draw like this. If you are standing, suppose here, if you are standing somewhere here, you have to draw from there. So wherever the observer is, if you draw a straight line passing through it, it's like a horizon. Now suppose the sun is here, okay. Now it is below our horizon. If we are seeing something is below horizon, we cannot see it. Something is above horizon, we can see it, right? Common sense. Now the sun is below the horizon. Ideally, you should not see it. That is a fact. If sun is here, sun is here, sun is here, we cannot see the sun. Are you getting my point? This is the night time. This is the night time. When the sun is below the horizon, the moment sun comes above the horizon, we start seeing it. Until it once again it goes below the horizon, we are seeing it. I hope you are getting how we are seeing the sun. But when the sun goes below the horizon, we cannot see it. But what happens when it is near to horizon? When the sun is near the horizon, see what happens. You are seeing from here. Light from the sun rays comes, let me draw rays, and atmospheric layers are there. Since atmospheric layers are there, let me draw like this atmospheric layer. It has to bend. When the light has to bend, obviously outside is vacuum and atmosphere has some denser medium. So it will bend where? Towards or away? Towards normal. So it will bend like this and come to your eyes. Instead of going straight, it will bend and come to your eyes. So even though the sun is below the horizon, for you, if I draw the apparent position, it will give the position somewhere here. For you, sunrise happened. But in reality, sun is not there, sun is below. But you are able to see the sun. So what we do? We are able to see an advanced sunrise. I hope you are aware that for our coast, we are in the eastern coast of India, Chennai. So we can see only sunrise, we cannot see sunset. Sunset can be seen only in Mumbai, that western coast, Goa, Mumbai, Cochin. That side you can see sunset, and here you can see sunrise. So sunrise, what we are going to see from our Chennai beach, is actually going to happen 2 minutes later scientifically, but we see it 2 minutes earlier itself. Same way, if you go to the western coast and when you are seeing sunset, the sun may be below the earth, below the horizon, it has gone below, but still the same thing happens. See here also atmospheric layers continue, no? It goes like this, bends and comes to your eyes. This is the apparent position, somewhere above. So because the sun is having apparent position above the horizon, even though it has gone below the horizon, you are still able to see it. So advanced sunrise and delayed sunset are also happening because of atmospheric refraction. If I draw diagram once again for you to draw in the school examination, you can draw like this earth, and you can draw atmosphere around the earth, you can draw horizon line, you can write it as horizon line, and then you can draw the real position of whom? Sun, real position of sun, and you can make a light to come from here like this, and entering the atmosphere, it will bend and go. Here is the observer, you can draw the observer here. So for the observer, the apparent position will be somewhere here. Okay, this is the apparent position. If they ask about sunset, same thing you can do. You can draw it here, and you can draw a line, you can bend it like this, and you can extend it in this direction, and you can draw the apparent position. Got my point? These are the apparent position of sun above the horizon, and below the horizon is the real position of sun. That is why we are able to see the sunrise 2 minutes ahead of the time, and we are able to see the sunset 2 minutes after the actual set. Okay, copy if you want to draw this diagram. This question comes, I will show you how the question is asked in the board exam also. Please copy it fast. Kamalesh is there, right? Kanishka is absent. Kavi Nitish is there. Muhammad Shakil. This batch is or that batch is? This batch only. Yeah, I know, man. Many are taking leave because of exam only. Darshini is there. No. Darshini is there. Yes, sorry. Sai Darshan is there? Absent, right? Sai Charan? You have come to this batch. Sanjana is not there. Santosh, Shriya is there, Srinidhi is there, Sudesh is there, and Vetrivel is there. Can I proceed? One last topic is remaining in this chapter, which is actually already taught to you in 9th standard chemistry, going to come in 10th standard physics. Learned about Tyndall effect? The same thing I am going to repeat now, with some physics involved in that. Shall I? Okay. So first, let us recall what is the meaning of Tyndall effect. So give the heading as Tyndall effect. You remember what is Tyndall effect? For understanding Tyndall effect, I am telling you an experiment to you. Please pay attention. I will give time for writing. Everybody, please pay attention. Suppose all of you would have played with laser light, right? Laser light, that red color, green color light. In the beach they will have, no? I hope you have seen the laser light. If you press the button, it will form something. If you put some head on the top, it will form some kind of images. I hope you understand what I am trying to say. So, if you have laser light, take a glass of water, clean water. Okay? So, one glass of water, I am talking about the tumbler also being of glass, and you pass laser through it. So, suppose there is a wall, there is a glass in between, and I am passing the light through glass. On the wall, will I see a red color dot or not? Is my question clear? I am having a glass of water, I am pointing a laser on it, and behind I have a wall. So, will this red color be visible on my wall or not? All of you agree to it? Yes, I also agree it will be visible. You will see a red point. Light is passing through water, isn't it? Will I see a red color light going from this water? Red line will be there? Yes or no? It will not be there. To go and try if you don't believe me. So, light is passing invisibly from here. Glass is there, light will pass through glass, but no trace of light in the glass. But on the screen, it will be visible to you. Screen means wall, it will be red color will be there. Now, what you do, in the same water, add some, don't end up adding salt, salt is not colloidal particle, add some milk, okay, some milk you add, and then stir the milk for some time. Same experiment repeat. Now also there will be on the wall some red light will come, but you will be able to see the light passing through the glass. Red color light you will be seeing through the glass. Is my experiment clear to you? If you want, you can try it. Very basic experiment in your home. If you have laser light, if you have a glass, if you have milk, if you have water, you can do this experiment in home itself. Take a glass, keep it in front of the wall, pass laser light with water, nothing will happen in the glass. In the same glass, add few drops of milk. Don't make it milk and light. Water, and that some milk is added. And then you pass the light, you can see the light is traced inside the glass when it is going to the wall. What happened so that light starts getting visible outside? Second experiment I will tell you. Not experiment, observation. If you see sometimes complete dark night and morning happened, early morning, but room is like closed room, make a small hole in somewhere, some point or through the window, light ray will be coming inside, and in the light ray you can see some particles floating here and there. Have you seen it? Seen that? Have you seen what I am trying to say? Sometimes if you see in the forests, in forest trees are there, through trees you can see streams of light coming inside. All these things, whatever I am talking to you now, whether it is the light coming through the window or forest light which is visible or this experiment itself, everything is the reason for all these observations is Tyndall effect. Now, what is the meaning of Tyndall effect? See what happens when light is going. Suppose I am having a particle, okay, a bigger size particle. If light goes and hits this particle, what happens? It reflects, this or not? Light, if it is not a medium for making the light to refract through it, it will reflect. Suppose there is a stone, I am hitting a light, it will go, it will reflect from there. So, if you have a bigger size particle, it reflects the light from it. But if you have a very small size particle, this particle is called as colloid, or we call it as colloidal particle. You know what is the property of this colloidal particle? Whenever light comes and falls on it, it scatters the light around it. So, the moment light is going and hitting small particles, it will scatter the light. So, what happened when the water was, only glass was filled with water, plain pure water, there were no particles in the glass, and so the light was going straight and there was no scattering of light. If, like he told, salt or sugar, if I would have kept salt or sugar, they are bigger size particles for light. So, what happens? Light will go and it will reflect. somewhere you may see some light coming out, but you will not be able to see the light scattered outside. But when you put some milk solution there, a drop of 2 drop of milk, milk has colloidal particles, which will make the light to scatter all around. If it is scattering light, we will be able to see through the glass some red light is passing. Anywhere you can see. Wherever you stand around the glass, you can see some red, because it is scattering light in all the directions. The same thing happens when the light is coming from the sun. When it is entering our atmosphere is consisting of small particles. It hits the particle, it scatters the light. Since it scatters the light, you are able to see the sky having some color. Which color? Blue color. You know why? Because remember this, higher wavelength light are scattered less. They are scattered less, and ulta. Lower wavelength lights scatters more. So, which is having more wavelength, red or blue? Red has more wavelength, yes, obviously, and blue has less wavelength. Since blue has less wavelength, it will have more scattering. That's why light coming from the sun makes the whole sky to look. Wavelength is the distance between two consecutive crest and trough, man. Now you may say light is a wave, huh? Yes, light is a wave only. You study in higher classes, light is a wave. Yes, tell me, man, Preetham.
Sir, but violet has less wavelength than blue, no, sir.
Yes.
Then why are we seeing blue and not violet?
Yes, good question. What Preetham asks, that we have violet only the least wavelength, no? Then we should see the sky as violet, not, why not blue? In the last class I told this to you, I think you are not there in the last class. I said that white light consists of 7 different colors, but these 7 different colors are not having same proportion. I told this or not? It's not like 1/7 is violet, 1/7 is blue, indigo, green, yellow, like not like that. Some colors are having more proportion, some colors are having less proportion. Blue has more proportion, Preetham. Red has more proportion, but other colors have a less proportion. So actually violet also gets scattered, indigo scatters, blue scatters, but blue scatters more because blue's proportion is more. One thing I will tell, listen to me very carefully, this is not there in syllabus, but I am telling you for your knowledge. If you go a little above the sky, I mean, suppose you are flying, from earth you start to fly above. The more up you go, the more up you go, the more up you go, no? Bluish color is becoming indigo, then it will become violet, then it will become black when you cross the atmosphere. Because, understand what is happening, light is hitting the particle, what is scattering first? Violet. Then what scatters next? Indigo. What scatters then? Blue. Blue has more proportion. By the time it reaches your eyes, only blue is scattered, so blue, 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 blue. If I ask you, in the evenings, why the sky becomes red, orangish or reddish, why? Any idea? Because see, in the afternoon time or in the morning time, sun has to travel, suppose this atmosphere, sun is somewhere here, it has to travel a lesser distance, right? But suppose you are standing here and sun is somewhere here, now the sun has to travel a longer distance to come to you. During sunrise and sunset, sunlight travels longer distance. So what scatters first? Violet, indigo, blue, green, yellow, orange, red. So by the time it is reaching your eyes, orange scattering starts to take place, orange red scattering. That's why it looks reddish in color. Understand the color phenomena, how it happens. What is scattered? So why I said you, when you go in this rocket, you are going up, right? So if you go a little more up, before the blue scattering, what scatters? Indigo. You will see indigo color of sky. You go a little more up, violet scattering you can see, violet colors of the sky you can see. Go more up, atmosphere you have crossed, it will become colorless, it will become black. What, you are asking something, Preetham? You are clear in this?
Yes, sir.
Yes. So please remember that whatever I have taught you now, this principle is called as Tyndall effect, And this phenomena is called as what of light? Scattering of light. And scattering of light is the reason why our sky is blue. If they ask you why to the astronaut the sky looks black, because astronaut crosses the atmospheric layer, and when he goes there is no atmosphere for scattering the light, and that's why the sky looks black. If the question comes, it will never come because it's not there in the book now, but if it is asked to you that why during the sunrise and sunset the sky looks reddish oranges in color, you can say that because during the sunrise or sunset light has to travel a bigger distance, and violet, indigo, blue, green, yellow, everything is almost scattered. So what is coming to your eyes is orange and red in color. So only sky looks orangish color or reddish color. Is it clear to you? If you have understood this, copy whatever you want to copy from the board. Write these things importantly. Higher wavelength is having less scattering, and lower wavelength is having high scattering. And if you want to write some statements, I will give the statement to you. Write the Tyndall effect definition. You write the scattering of light. Leave some space and write now first. I am telling. Scattering of light by small particles, in bracket you can write colloidal particles. Here it is there. In bracket you can write colloidal particles is known as Tyndall effect. You can change the paragraph and write light having higher wavelength scatters less, whereas the light having lower wavelength scatters more. Smaller wavelength scatters more. This is the reason why our sky is blue. That also you can write. This is the reason why our sky is blue. Okay, is it clear to everybody? Can we go to some questions now from the past papers of the board examination? Shall we see some questions?
No doubt, sir.
Ask me then, whatever you want to ask.
Sir, when light hits bigger sized particles,
Yes.
you said it will reflect.
Yes.
Does it follow the laws of reflection?
Definitely it follows the law of reflection. Whenever light is reflecting, it will follow law of reflection.
Sir, for the 7 colors you said proportion, sir. What do you mean by that, sir?
I mean that,
Is it the
yeah,
mass or
not the mass, the content I am asking. So it is not like the scattering of each color will be equal. Scattering of blue will be more compared to indigo and violet. Scattering of orange and red will be more compared to yellow or maybe green, all these colors. So some lights are more and some colors are less in the white light composition. We say that white light is composed of 7 colors, right? In 7 colors composition, each color is not having equal composition. That's what my point is. I hope you understood, Nitin Raghav.
yes, sir.
Yes. Is it visible to you, the screen, everybody? Is it visible? Okay. Let us see the question that has come in the past papers, shall we? I hope it is visible to everybody. Shreya, Daksha, visible?
Yes, sir.
Yes, see the first question. Fast. This question has come last year also in the board paper. See what is the answer. When a beam of white light passes through a region of very fine dust particle, the color of light that scatters the most in that region is Red. Very good.
Blue.
Obviously blue, man. What I told now. Which color will have scattering more? Blue, right? Red will have less scattering, man. It's like more wavelength. So what is the answer for this question? Blue. Got it, Priyaranjan? Sure, understood? Next question you see. Select the correct answer from the following. This question also last year came. See all the options. See what is true. A, B, C or D. Think and say. C? All of you agree with C? I also think C only. Obviously C only. Sunlight passes through the fine particle, they scatter the blue color of the visible light more strongly than red. Yes. Anybody has doubt in this question? No, right? C is the answer. 57th question C. Once again, 2 years back came in the board examination. I told in the class also. A, B, C or D? B?
D, sir.
D?
D.
Delta?
Yes, sir.
Whether scattering is taking place by rainbow? I don't think so. Last class you were absent.
Total internal reflection has taken place, sir.
Yes, it takes place. So you are saying that the word total is missing here in these two, B and C. No, don't think that much, man. Answer is B. The three phenomena are refraction, dispersion, and obviously TIR. But here they have mentioned the word as internal reflection. Answer is B for this. Got it? I hope it is clear to everybody. Shall I go to the next paper? Yes. See how the question came. 2-mark question it is. 24 it came. Name the phenomena of light responsible for Tyndall effect. Scattering of light. Write an event where this phenomena can be observed. Experiment you can write, or you can write find light in the forest you can write, or you can write the blue color of the sky. Anything you can write. They are asking one example. So anything what is comfortable you can write. Next question you see. The color of clear sky from the earth appears blue, but from space it appears black. Why? There is no atmosphere to scatter the light. Since there is no scattering taking place in the sky, in the space, the color of space is black. 2-mark question this is. But they will give marks only if you write properly. On the earth, we can see the atmosphere which scatters the light. If you go above the atmospheric layers, no scattering takes place because there is no atmosphere present in the sky. Yes. Next question, see here, 60 seconds. Danger signal installed at airports and at top of buildings are of red color. Why? 3-mark question it is. More scattering. Less scattering, because red is having high wavelength, it scatters the less. So you can see from very far also red color. Are you getting a point? If red scatters, we will not be able to see, no man. Since red has very longer wavelengths, red can be seen from a very long distance also. That's why we prefer red for danger. Okay. B, same question. Sky appears dark to the passengers flying at high altitudes because atmospheric layer. Yes. C, path of beam of light passing through colloidal solution is visible. Because colloidal solution means it will scatter the light. Yes.
Solution is large enough to scatter the light.
Yes. That's the answer. Got it? Are you seeing the questions how it is coming? Whatever we learned now, theory questions are coming from there. No numericals. Once again, same question repeating. Red color is selected for danger signals because it has higher wavelength. Right? See some more questions there. Similar question. This C part you see. The time difference between actual sunset and apparent sunset is about 2 minutes. They want to write in detail. 1.5 marks this is. Sorry, 1 mark this is. What will you write? Because of atmospheric refraction, the apparent position of sun at sunset and sunrise appears to us 2 minutes before early. and in the case of sunset 2 minutes later. Got my point? That if you write in proper words, they will give 1 mark to you. Once again, 64th question we have learnt now. Why is Tyndall effect shown by colloidal particles? Because colloidal particles scatter the light falling on it. That's why it shows Tyndall effect. State 4 instance of observing Tyndall effect. All these experiments only, that water in the milk in the water, or in the forest area, in the windows, and in the sky. Anything you can write. 4 example they are asking. 65th question, again a 3 mark question. What is the answer for the first part? See fast. 65A.
Sir, the larger the particle, the more the light is scattered, and the light with lower frequency.
Not frequency, wavelength.
Wavelength. Light with less wavelength scatters more.
Yes, I'll tell you one thing. Please pay attention. Always remember that the wavelength of light and particle size have proportionality between them. It means a smaller size, if hit by a light of lower wavelength, will scatter more of which color it will scatter? Lower wavelength means violet, indigo, blue, like that. They will scatter the blue light. Are you getting a point? And for able to see the scattering of red color, you must have a greater size particle. Are you getting what I am trying to say? If you want to scatter a bigger particle, if you want light to get scattered by a bigger particle, it will scatter only bigger colors of light. Bigger colors means that red and orange and this thing, yellow. But if you want to see bluish, it should have a smaller particle. Apparent position of object when seen through a hot air fluctuates or waves. State the basic cause of this observation. Atmospheric refraction. That's all. Complete the path of white light. What will you do here in this diagram? Last class I told you this thing to you. First you will draw 7 different colors. Once again you will combine both and straight line coming out, white light coming out. Newton's experiment, right? This is Newton's experiment. First prism will disperse the light in 7 colors. Once again second prism will combine the 7 color and make white light. I hope you know this. Okay. Next we will see. So what they are asking you, see. Choose the correct option for the color of rays for A and B. Blue, green, red, violet. Choose the option. A will be what? Red. B will be violet. Violet, indigo, blue, green, yellow, orange, red. Because red deviates the least, it has the maximum wavelength. Violet deviates the most because it has the less wavelength. So, what is this here? Once again Newton's experiment. What will happen here? 3 prisms are there.
So first 7 colors will come.
Yes,
Again
one color, but so on screen will be what there? 7 colors. Violet, indigo, blue, green, yellow, orange. So what colors will be seen on the screen? 7 colors. Copy the diagram above and draw the beam entering prism 1 and emerging from prism 3 on the following screen. I think you can draw that, right? You will make 7 colors to go like this, then 7 colors coming here, becoming white, once again 7 colors scattering and becoming on the screen. That you can draw by yourself, I think. Then what is there? Name all the process that takes place when the beam of light enters the prism 1 and emerges from 3. Tell me what happens here? Scattering. Dispersion. Why internal will happen here? What is the one more thing is refraction. So two phenomena are refraction of light and dispersion of light. No atmospheric refraction here and no scattering here. Don't confuse in all these things.
Sir, the phenomenon for converting the 7 colors of light into white light is what, sir?
No, it is a part of dispersion only. Reverse, we can say reverse dispersion. But no need of mentioning that. If you write dispersion, it is enough. Okay. When light enters the atmosphere, it strikes on extremely fine particles which deflect the rays. Answer is? Think and say. Atmospheric refraction.
Option C, sir.
Scattering, man. Light enters the atmosphere, so you let answer as atmospheric refraction. No, see, it strikes on extremely fine particle which deflect the rays of light in all possible direction. This is due to atmospheric refraction. Sorry, scattering of light. So C is the answer. 8th question. Again a question based upon atmospheric refraction. Once again, we will go to the next question. Time is also not there. Yes, see here. Which of the following is the correct reason for twinkling of star? A, B, C or D?
B.
Obviously B, because A is atmospheric reflection. It is not reflection, it is atmospheric refraction. Okay. 3-mark question, you see how the question comes. Explain in brief the reason for each of the following. Advanced sunrise you can write. What will be the answer? All 3 have same reason. What is the reason? Atmospheric refraction. But since they are asking 1 mark for each, you should draw and explain at least one line. These both you can do together also. Okay, and third one is twinkling. Change in the apparent position of star. Got my point? So I hope you are clear in how the questions are being asked in the board examination for whatever I have taught today in the last class. Right? Again, in this chapter, you may have questions coming from numerical part of defects of eye. Very rarely coming, but sometimes comes. And obviously, light chapter has a lot of numericals involved in that. So tomorrow's 7 to 8 p.m. class, I told you every Thursday hereafter, from 7 p.m. to 8 p.m., there will be a practice class for physics also, where we will be doing numericals from whatever we have learnt. Math practice class. Yes, every Thursday hereafter, 7 to 8, physics practice class will be there. It will be held in the main building, 2nd floor. Math here only.
8 p.m. or 7 to 8 p.m.
7 to 8, Nitin. 6 to 7 is already math practice class on Thursday. That will continue how it is continuing. Additionally, 1 hour we are giving from 7 p.m. to 8 p.m. Main building, 2nd floor. The class will be held. It will be taken by Shrey sir, and he will be doing numerical solving from light and human eye. What, Preetham?
So you have to attend the class from 6 to 8.
No, but you are not required for that because you will be online, right? So you need not to come here. This is only for students who are coming in the center. Okay, Preetham?
Okay, sir.
Yes.
Sir, another doubt.
Please tell me, Nitin.
Sir, when other types of light other than white light enters glass prism, it occurs only refraction, or does it also occur dispersion?
You are saying that when a white light is entering a prism, what are the phenomena taking place? That is the question?
Yes, sir. Does
Yes.
it only experience dispersion or also?
Also refraction. Refraction as well as dispersion. Both are happening.
Sir, but the other lights, when they are entering the prism,
You are
only
saying
refraction takes place or-
like monochromatic light, you are saying, right?
Yes, sir.
Only refraction. A good question. If he is asking if only red color comes inside, whether the prism will make it dispersed or make it refract, only refraction will happen. If it is monochromatic light, means only one color light, it will have only refraction. If it is white light, it will undergo dispersion also. Got my point? Okay. Bye-bye. Take care. Good night. Prepare for the exam well. We'll meet again in the next class. Take care. Don't forget about tomorrow the extra class.
Sir,
Tell me.